okay? It won't hurt you to hear it. Okay, I was about here, okay? Now, I've changed something a little bit. We ran out of memory somehow, and I didn't get most of this, but it's straightforward, okay? So, we have this equation. There's no x. So we can let v equal x prime. And then x prime is now v, and x double prime is v prime. That's just a change of variable, which is convenient if you have a higher order equation that's missing terms after a certain derivative. So after the first derivative, it's missing the function itself. We can do this. If it was missing the second, first derivative and the function, we could let v equal x double prime, okay, and so forth. Actually, we use triple prime on that one. Okay, so anyhow, we do that, we get this equation. It's an easily separable equation. So we rearrange the equation and we get this. The rearrangement's straightforward. We divide both sides by this, and we sort of multiply the dt, but we actually just rearrange it into this form, and we divide by m. Then our antiderivative with a straightforward substitution, u equals f at minus gamma v. Okay? Well, I'm not going to detail that, you just need to review substitution. Gives us this. Okay? So, multiply by negative gamma, we get this. Okay, very straightforward. Then if the natural log of the absolute value of this thing is equal to this, then what's inside the absolute value sign needs to either be plus or minus e to this. Okay? Either way, whether it's plus or minus, the absolute value sign is just going to give you what this does, and you need to work that out. You almost certainly saw this in your first year calculus, so those neurons ought to be at least have some residual connection. If not, make it now. And don't forget it, because it comes up again and again. Okay? Then f at minus gamma v will be, well, first this is plus or minus this, and then that comes out to just the laws of exponents, e to the c times e to the negative gamma over mt. E to the c can be any positive number. It can't be negative, it can't be zero. We talked about why, but that's basic pre-calculus and how exponents behave. So convince yourself of that. Make sure you understand it so that you have that understanding when you need it. But we're going to replace e to the c with a. Actually, we're going to replace plus or minus e to the c with a. So a can be anything but zero. E to the c can be any positive number. So negative e to the c can be any negative number, but can't be zero. So any a except zero. Of course, if a is zero, you're messed up anyway. Okay?
Yep. Question.
And then, with that, we solve for v. It's very straightforward. Just subtract f at from both sides, divide by negative gamma, and this is what you get. And, you know, a absorbs the negative gamma. Gamma is not zero. Okay? So the constant a just absorbs the constant gamma. And there's your solution. Okay, and note that this is incompatible with this. The units aren't the same. We have for example, we have an f app over gamma in our v. And if v equals x prime, then the derivative of this ought to have an f app over gamma. And it doesn't, and I pointed out that that can't happen. Okay, you can't get rid of it, so there's something screwed up in my original solution. This confirms it, and maybe gives us some insight as to what to look for when we try to figure it out. Yeah?
You, a times e to the, isn't that a 2? Not a
Isn't it
gamma?
what?
Isn't it a 2, not a gamma?
A 2.
Yeah.
I don't think there's any 2 in here, but let's make
It
sure.
was where you multiplied by, or you had the negative 1/2 and brought it to the other side, made it a negative 2 over m.
You don't have a negative 1/2. That's a gamma there.
Oh. All right. That makes
I was
more
trying to
sense.
really make it not look
Yeah.
like. Of course, 2's can have loops in them too.
Yeah.
Yeah, now it looks a whole lot like a 2. Okay.
All right. Okay.
Okay, these are all gammas,
Okay.
and if you work it out yourself, you'll see that. Okay, well, so there's that. Now,